And here is question number 8 of WAEC 2025 further mathematics examination, the theory questions. A force of F Newton acts on a body of mass 50 kg and changes its velocity from 30 meters per second to 40 meters per second in 6 seconds. We're asked to find the magnitude of the force, the acceleration of the body, and the distance covered in 9 seconds when the initial velocity is 30 meters per second. Let's get started. I would like to start with the B part because we have to use this acceleration in solving the magnitude. So let's start with the B part. The B part, what are we looking for? We are looking for the acceleration of the body. So we are going to utilize this formula, which is V equal to U plus AT. So we can now make A the subject, subtract U and divide by T. So it is going to be what? A equal to V minus U divided by T. V here is the final velocity, U is the initial velocity, and T stands for the time. I'm going to squeeze this place. So where is our final velocity? Is 40. We're going to discard the unit till the end. 40 minus 30, right? Okay, let me drop down here. 40 minus 30 divide by what? 6. All right, so let me use my calculator. (40 minus 30 divided by 6). This is equal to 1.67. 1.67. This is equal to 1.67. This is A. And the unit is what? Meter per second squared. Meter per second squared. So we are done with the B part. Now let us come to the A part. We are looking for the magnitude of the force. So we are going to use Newton's second law, right? Which is F equal to the mass times the acceleration. The mass of the body is 50. So this is 50 multiplied by A, which we have here as 1.67. 1.67. You should know that there is difference between dot product and decimal point. Decimal point is always aligned with the numbers, while dot product is at the center. All right. So we have 50 multiplied by 1.67. We have 83.5. 83.5. And what is the unit? Newtons. So the last one, which is the D, we are looking for the distance in 9 seconds. So we are going to use this distance formula. This is C, right? S equal to UT plus half AT squared. U is the initial velocity, which is 30. T is 9. So this is equal to 30 multiplied by 9 plus half. A is 1.67. Do I have more space here? So let me see. 1.67. And then T, that is, what is it? 9 squared. Oh my God. Honestly, this is too tight. I know what to do here. Let me shift this one. Let me just clear the question, no problem. I want it to be so clear that everyone can see it. So it will be equal to 30 multiplied by 9 plus half. A is 1.67. Then T is also 9 squared. So let me see. Let me start from here. 30 multiplied by 9. We have 270 here. 270 plus 1.67 divide by 2. This is what we have. And we're going to multiply that by 9 squared, and 9 squared is 81. So times 81, we have 67.635. Add it to, okay, let me write it here. 67.635. And lastly, add it to this one. We have 270 plus 67.635. We have 337.64, right? Should I? Okay, 64 in 2 decimal places. And the unit is what? Meter per second. So this is the distance after 9 seconds. Yeah, no, S, sorry. We're done. Now let us move on to question number 9.